Alright, now we're going to talk about tangent. So, just a quick refresher. Tangent of an angle is equal to the side opposite that angle divided by the side adjacent that angle. And an important trig identity to know is that tangent of an angle is equal to sine of that angle over cosine of that angle. Now, how can we prove this? Well, we know sine is the same thing as opposite over hypotenuse. We know cosine is the same thing as adjacent divided by hypotenuse. And actually, let me rewrite it like this. So we have opposite over hypotenuse, which is sine, and we're dividing this by adjacent divided by hypotenuse, which is cosine, right? Sine divided by cosine. Now, because this is a fraction, we do like to keep change flip. So we're just going to change this to multiplication. And then we're just going to flip this fraction. So it's going to be hypotenuse over adjacent. Now we multiply these two things together. Hypotenuse cancels out. And we're just left with opposite over adjacent, which is what tan is, right? We said tan is opposite over adjacent. So just by doing some of this simplifications, we get that sine of theta over cosine of theta is equal to tangent of theta. And we can also verify this using the unit circle. When we create an angle on the unit circle, the point where the ray, so when you draw this ray, right, it creates the angle. The point where this ray intersects the unit circle has the coordinate cosine of theta, comma sine of theta, which means that if you create this right triangle, all right, so you just draw an altitude down from the point, that means that this part of our triangle right over here is cosine of theta. This represents the x value of this point, right? This represents the x value of this point. And sine of theta represents the y value of this point. Sine of theta represents the y value of this point. Tangent is equal to the side opposite this triangle divided by the adjacent side. So the side opposite this angle is sine of theta. And the side adjacent to this point is cosine of theta. So tangent is sine of theta over cosine of theta. Now let's say I created an angle on the unit circle. And I want to find out the slope of this line. So I want to find out the slope of this line. Well, how can I do this? Well, recall that when you want to find a slope of a line, it's just going to be your change in y over your change in x. We know that the coordinate of this point is going to be cosine of theta, comma sine of theta. We also know that this ray intersects through the origin, right? You can see how when I drew this ray, it intersects the origin, right? It doesn't matter. It doesn't matter what angle I create on the unit circle. So let's say I create, let's say this angle, for example. When I draw the altitude downwards, well, you'll notice how, right, one of the points of this ray is this origin, right? So wherever you draw an angle on the unit circle, it's going to intersect the origin, right? So we know that this point right over here is cosine of theta, comma sine of theta. I know that this point right over here, the origin is just 0, 0. So applying the slope formula on y2 minus y1 divided by x2 minus x1, we get that this is just going to be sine of theta minus 0 divided by cosine of theta minus 0, which is just equal to sine of theta divided by cosine of theta, which we know is tangent. So the main point I'm trying to get across is that tangent represents actually the slope of this ray. So if I draw, let's say, another unit circle, let's say that I create this ray right over here. Well, tangent is going to represent the slope of this ray, right? Because we know tangent is the same thing as sine divided by cosine. And sine, we can think about this as our change in y. And cosine, we can think about this as our change in x. So change in y over change in x gives us our slope, which is tangent of theta.